Okay, so previously we looked at an example where we were able to show the difference in wages between male and female, and we said that although education has an impact on wages, but this impact differs across gender. And we showed this type of graph to represent this type of relationship. And this graph was showing us that education determines wages, but men, they were paid differently as compared with women on average. In particular, we talked about the difference in the intercept between men and women in this case. But sometimes we are interested in knowing whether the slope of the line differs across different groups. In this example, we may be interested in knowing whether return to education differs across men and women. That is, whether the slope of this line with respect to education, it is different for men and women. And we can represent this type of relationship by interacting dummy variables with other explanatory variables that are not dummy variables. For example, in this case, the other explanatory variable is education, and we can interact this gender dummy variable with this variable to show differences in slope. So I'm going to continue talking about this example. I'm going to introduce a model where we will be interested in knowing the difference in the return to education across men and women. We are interested in a model like this model. So this is a dummy variable for female, and then we are interested in knowing returns to education. What I'm going to do, I'm going to introduce another interaction term, and this interaction term is between this dummy variable female and this explanatory variable education, and plus an error. So now we can show that percentage change in wage with respect to change in education, it is equal to beta 1 plus delta 1 female. For female, it will be beta 1 plus delta 1, and for male, because this dummy variable is 0 for men, so the slope of the line will be beta 1. So essentially, delta 1 here, that is the difference between the slope of the line between men and women. We can represent different type of relationships using beta 1 and delta 1 as an example, and I'm going to show you two of those. So for example, we already know that this is the line for men. This is the intercept. We already know that the intercept differs across men and female, which is shown by this delta 0. So we already saw in this in the previous example. What we are saying here is that delta 0 is negative, right? So this difference is delta 0, right? So this is the slope for men, which is beta 0, and for female it is beta 0 plus delta 0. And we know that delta 0 is negative because the intercept of the line for female it's less than the intercept for men. If we look closely, we also know that in this case delta 1 is negative as well. So if we look at the slope of the line is larger for men and the slope of the line is flatter for women. Similarly, we can show another scenario as this. So although the intercept is low for women, the slope of the line is greater for women than for men. So what does this mean? In the first example, it means that return to education are larger for men than for female. And in this case, what we are saying is that return to education are larger for women as compared with men. And essentially, we are interested in knowing whether return to education, that is, whether an additional year of education pays equally across these two genders. So what we can do is we can test hypotheses that whether this delta 1 coefficient is equal to 0 against alternative hypotheses that it's not equal to 0. Let's look at an example in R. Okay, so I'm using this wage 1 data set, and here I'm including a dummy variable female in the model, and I'm interacting it with the education. And remember, education is an explanatory variable which is not a dummy variable. And this star means regression model will include a dummy variable for gender and education variable separately as well as an interaction term. So let's look at the results. Okay, so our variable of interest here is this education variable. So what this coefficient value is telling us is that the return to education for men is about 0.8 or 8.2%, right? So remember, this coefficient value represents return to education for men. This means holding all other factors constant, an additional year of education pays 8.2% for men. So what is this impact for women? It is, as we see here, beta 1 plus delta 1. So let's look at these two coefficient values. So it is 0.082 plus this coefficient value, which is the coefficient on the interaction term, which is minus 0.0056. So we add these two and get the impact as 0.07 or 7.6%, right? So the difference is delta 1 across these two groups. So this is a difference. So this is the difference in the slope across men and women. That is, whether an additional year of education pays differently across these two genders. But looking at the t-value, we fail to reject the null hypothesis that this coefficient value is no different than 0, which means this impact is statistically insignificant. Therefore, we conclude that there is no evidence that return to education differs across men and women. So that's how you introduce different slopes using a dummy variable. Okay, I'll see you in the next video to talk about how to test for differences in regression functions across different groups. And then finally, we'll talk about linear probability models. All right, I'll see you in the next video. Bye-bye.